and grow more and more dense, until some coalesce into the first stars. These are giants, hundreds of times bigger than our sun. They burn out quickly and dramatically, in the flash of a supernova. What's left at the core is a black hole.
Perhaps the black hole becomes the seed from which the galaxy sprouts. The gravitational seed that is used as an attractive force to accumulate the rest of what we would today then call the greater galaxy.
Possibly seeded by black holes, the infant galaxies dance and orbit one another as gravity pulls them closer. So our Milky Way galaxy, as this time-lapse simulation shows, was not born in one single event. Instead, it was built over billions of years from a swarm of smaller galaxies smashing together, merging.
But if another galaxy comes too close, they will each feel each other's gravity. And in that collision, what started out as a stately ballet of stellar orbits moving around the center of their galaxy has now become this maelstrom. There's no other way to say it. Galactic cannibalism, that's what they're doing. They're dining on their neighbors, eating entire galaxies. Well, for every galaxy you eat, if that galaxy has a black hole in its center, it's going to eat the black hole. The black hole will work its way down to the center of the large galaxy, making the center of the galaxy bigger as well as the galaxy itself. It's just that simple. The big galaxies get bigger, and the little ones get eaten.
Galactic cannibalism is how galaxies grow, and with them, the black holes at their centers merge and grow bigger. But what does the presence of such a monster mean for the life of a galaxy? Brian McNamara believes he's found the answer, and it isn't pretty.
That's it right there. We got it. That's it. Okay, so you want to go...
McNamara studies the life cycles of the universe's biggest structures, galaxy clusters.
There it is. That's the galaxy. So that's what we've been looking for. This is the giant central galaxy in a galaxy cluster. And each one of these little dots here on the screen is a giant galaxy as big as our Milky Way, maybe even a little bit bigger. And they're all bound together by their own mutual gravity. So they're all buzzing around this giant galaxy like bees buzzing around a hive.
McNamara probes his galaxies with multiple tools. Optical telescopes, radio receivers, even X-rays.
Ah, there we go. Check that out.
X-ray images reveal a vast cloud of hot gas through the whole cluster, across hundreds of thousands of light years.
There's an atmosphere of gas that pervades the entire galaxy cluster, and it's an atmosphere like our atmosphere, except that it's far less dense and it's much hotter.
But when McNamara looked at X-rays of the gas around certain clusters, he saw that vast clumps of it appeared to be missing.
I was blown away. I'll never forget the moment we got the observations, and lo and behold, these two giant cavities showed up in the X-ray emission.
The size of the cavities was astounding.
That's 200,000, 600,000 light years from end to end. So between that cavity here and this cavity here, we could stuff 600 Milky Ways in there. It's just astonishing. The energy involved is huge.
Something powerful had pushed the gas away, across vast regions of the universe. McNamara traced the power source to the center of a giant galaxy, a supermassive black hole.
So we could see the beam coming out of the black hole and ending up in these big cavities.
But how can a black hole, a creature famous for devouring everything within its grasp, spew energy across the universe? The answer lies in the way matter falls toward the black hole. It turns out, nothing goes straight in.
As matter falls in, what we know now is that it spirals around in a disk, okay, very much the way when water goes down the drain. It doesn't just go straight down the drain.
Just as water spirals down a drain in a whirlpool, matter and light spiral at high speed into a black hole.
And the speeds that matter can achieve around that black hole approach the speed of light. And when matter travels at that speed, it gets a tremendous amount of energy.
Matter falling into a black hole is a lot of stuff trying to get into a very small place. And so it's like trying to fill a dog dish with a fire hose. Most isn't going to get in.
The black hole chokes on the influx. And the high-speed whirlpool of matter produces a powerful magnetic field, coiling around the black hole and shooting the energy outward. These enormous jets of energy, hundreds of millions of times the power of the sun, can blast right out of the galaxy.
There's no question that the black holes at the centers of galaxies have a profound influence on their surrounding. They send out these huge jets moving at almost the speed of light. And those jets can send shock waves into the surrounding medium and change their surroundings completely. They have a dramatic influence.
Not only can they blast away huge quantities of gas, but they may even sterilize the galaxy, so new stars can't form.
The supermassive black holes at the center may be responsible for limiting the size of galaxies. In principle, galaxies can grow to very, very large sizes, and what we see in the universe is that they don't. And we think that the supermassive black holes at the center may be the culprit. They may be responsible for preventing runaway growth of galaxies.
We usually think of black holes as God's dumpster, but they really are actors on the galactic stage.
If supermassive black holes can wreak so much havoc, what's to stop our own monster of the Milky Way from wiping us all out? It all depends on the monster's diet.
Most of the time, a black hole isn't eating. It fasts more than it feasts. But when a black hole feasts, it can have a tremendous effect on the surrounding galaxy.
The more black holes chow down, the more matter and energy will blast outwards.
One of the key differences between galaxies with supermassive black holes is whether or not their black holes are lit up, because they're basically binging on a lot of material in its surroundings.
For years, our black hole seemed to be fasting, and the Milky Way was peaceful. But in 1999, the Chandra Space Telescope detected a powerful signal from the galactic center.
Station 34, Chandra OC.
An explosion near the event horizon. Is this the beginning of a black hole binge? For trackers of the galactic center, the blast is a wake-up call.
It was a hot piece of news. A remarkable fact for all of us was, for many years, how inactive the black hole was. And all of a sudden we saw, well, there's an object there which wasn't there before.
Reinhard Genzel has been watching the galactic center for nearly 2 decades. Like Andrea Ghez, he's been tracking the orbits of stars, helping to prove the existence of a black hole at the heart of the Milky Way. Now both Genzel and Ghez will shift their focus and try to measure the black hole's appetite.
One of the big mysteries about the black hole at the center of the galaxy is why don't we see emission from matter falling onto the black hole, or rather the black hole eating up its surroundings.
Genzel and Gez are joining a worldwide effort. Chandra in orbit will take X-ray pictures of the galactic center. At the same time, 5 major observatories on the ground will probe the black hole, all trying to count calories. Genzel heads south to Chile, while Gez and Becklin climb a mountaintop in Hawaii. Telescope time is precious. There's no room for mistakes.
When you're there, it's an incredible rush. I mean, you're very much on for the few nights that you're there, hoping the weather cooperates, hoping that the instrument cooperates.
How's the Act 4 look on the oscilloscope? Does the timing look okay?